Welcome everyone to day 15 of Advent Decode. It's been going okay. The TypeScript experiment, my first year doing TypeScript for this, has been working so-so. It's been not too bad, but also I feel like I've been solving these a little bit slower than normal, and also running into some more issues, but overall, can't complain. All the visuals I've been doing have been fun to do as well, but at any rate, day 15's code and input is ready to go. 5 seconds here till we start. Fingers crossed it doesn't go too bad and we can solve this pretty quickly. But let's do this. The newly focused parabolic reflective dish is sending all of the collected light to a point on the side of the yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find the door under a large sign that says Lava Production Facility. Next, smaller sign that says Danger. Personal protective equipment required by this point. On a step, you immediately greeted by someone panicked reindeer wearing goggles and a loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats to find that fits. Further in the facility, at one point you pass a button which, with a faint snout mark and the label "Push for Help." No wonder you're led to the tribute so quickly. You pass through a final set of doors surrounded with even more warning signs into what must be the room that collects all the light from the outside. There are some lenses available to further focus light. The reindeer brings a title book, Initialization Manual. Oh, is this gonna be like a code program thing? As you admire, begins apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use Holiday ASCII String Helper algorithm. You turn to appendix. The reindeer leans closer to interest. The hash algorithm is a way to turn any string of characters into a single number in the range of 0 to 255. To run the hash algorithm on a string, start with the current value 0, then for each character in the string, starting from the beginning, the ASCII code for the current character in the string, increase the current value by the ASCII code just determined, set the current value to itself multiplied by 17, to the remainder of dividing itself by 256. After following the steps for each character on the string, the current value is the output of the hash algorithm. Hash 0 h 72, current value increases to 72, current value is multiplied by 17, S code 65. Okay, so the final is 52. This sequence is a comma separated list of steps to start the lava production facility. Ignore new line characters when parsing the initialization sequence to verify your hash algorithm is working. Wait, what? Ignore to verify hash. The book offers a sum of the result of running the hash algorithm each step. In this initialization sequence, for example, rn equals 1 becomes 30. Ah, gotcha. Okay. An example: the sum of these results is that unfortunately the reindeer stole on the page containing the expected verification number and is currently running the facility with it excitedly. Run the hash. Okay, so yay, fun. All right, this shouldn't be too bad though. This is a pretty straightforward, goodness. All right, so input, splits on, commas and map, and we're gonna do s.splits on each character and map that. As there's a chart code at, we can just do 0. I believe that's Unicode, or not Unicode. I believe that's ASCII. I should probably verify. Actually, we'll find in a second. Actually, I can just do. I can do console log. I think I should get an example. I think it's big A is 65, right? Actually, I think H is 72. Okay, yeah. Chart code at 0. Let's just verify that this is correct. 72. Okay, cool. All right, so here that we have that. So, actually, we can just do the steps here. Actually, no, because we need to call reduce. And reduce sum C and start at 0. So all it's going to be is return sum plus Actually, sum goes a part of this. It's sum plus c times 17 and modulus 256. And that should be part 1, right? Am I not mistaken? Oh. I'm missing a reduce. I need another reduce. Yeah. I do need one more reduce, which is going to be sum, subsum, subsum plus sum. Beautiful. All right, now how hard is this going to get? You convince the reindeer to bring you to the page. The page confirms that your hash algorithm is working. The book goes to describe this series of 256 boxes numbered 0 through 255. The boxes are arranged in a line starting from the point where the light enters facility. Boxes have holes that allow light to pass from one box to the next all the way down the line. In each side of each box, there are several lens slots that will keep lenses correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. All along running parallel to the box is a large library containing lenses organized by focal length. 1 to 9, the reindeer brings you a small handheld label printer. The box goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual K hash map. Nice. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm and the label indicates the correct box for that step. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. If the operation is a dash, go to the relevant box and remove the lens with the given label. If it is present in the box, then move any of the remaining lenses as far forward in the box as they can go without changing their order. Filling any space made by the indicated lens, nothing happens. Will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. In the relevant box, be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find it later. If there's already a lens in the box with the same label, replace the old lens with the new lens. Move the old lens and put the new lens in its place. Not moving, okay. If there is not already a lens, add the lens in the box immediately. Behind any lenses there. Okay. Box 0, R, and 1. Okay, so... Okay, so const hashes... so how do we want to do this? So... Actually, we're going to do... Screw that. Do this. Do this. So this gives us each one of these. So now we need to do a map on these. I guess we need to do a for each, don't we? Boxes. Key string. Okay. So for each one, so now we're gonna have so this is but that's mapping on char code. Okay, no, get rid of that. Don't map on char code. No, don't do that either. Yeah, no, don't do that either. Okay. So we're gonna give this is just a step. Let's call this an operation. Call this an op. So the hash, so const get hash, pass in the string, and all it's going to be is this. Okay, so now we can just run get hash on the operation. So now we have the box number. But actually what we're gonna do is if, are they all? No. Okay, so we're gonna do is if op dot contains, or includes, sorry, no, includes, an equal sign. This is the easier one, so we just go ahead and drop it in, but we do need, actually gonna be a string array, right? Yeah. Wait. Okay, it goes in, okay. So is the box number equals, so now we need to make sure that boxes, this is actually a number, boxes, box number includes, actually, we do need const op, just make this label, op replace the equal sign with a space. Actually, we can just do box number equals boxes, box number filter, label does not equal label, and then go ahead and add label. That's nice and easy. Otherwise, we have, we need to remove it. So we need to boxes equals we need to remove boxes. So we're gonna do const key equals find boxes key includes I need the label, which is just dropping that. Okay. Includes label. If it finds the key box, we're gonna do this again, except we don't need that. We can just do that. Key. Cool. So that should build up our big giant list that we need. Reading filter 15. Oh, because you do that. No errors? Beautiful, no errors. Okay. So now all that's missing is this. So at the end of the build, for example, the focusing power of each lens is as follows. RN1. Okay, so now we need to call... Index, okay. So at the end of this, we're going to call reduce. Oh, sorry, no, it's going to be at this. We're going to need to call const. Sum part 2. Sum box return sum plus const. We need the box number. Sorry about the train going by. That's really loud right now. Okay, so there's the box number. So it's gonna be sum plus box number plus 1 times actually focal length is that. Okay. So no, we need to actually instead do boxes, box number, reduce, subsum, lens, that, just that. I guess I'll start to 0, just like this one. This is gonna return so this is gonna return the logic here. So it's gonna be box number plus 1 times the index plus 1 times, so we need the focal length, lens substring lens index of space plus 1, parse the integer from this times the focal. Part 2. Is that it? I get a number. We plug the number in. It's not right though. Okay, the whole the box that doesn't make sense to me. Clearly it should be box 30. How is it box 0? Is it because, hold on, is it, I'm missing the fact that the label is, okay, actually, so I think it might be this. It might be substring op dot index of the equal sign. Obviously it's a little bit different because it's 0 to that. So there's the label. That means that label is this. We don't put this label. Actually, but we don't put the label in. It goes in there. Replace. This is what goes inside. Change it from label to content. And that can stay there. All right, so does that fix it? I get a different number. No. All right, what is... Give me some test input. $3.95 is not right. Console log label. What am I getting for my labels here? So RN 0. Okay, so that was the issue. RN is 0. And the rest of these look correct. Okay, so that was the issue. It was the label. Good to know. That's fixed. That's been addressed. I'm gonna do this. Just don't have to keep doing it each time. Okay. Okay. So that means now I'm down to part 2 here. So actually, if I do a console.log on my boxes, does this match? The remove doesn't work. Okay, so my remove logic didn't work. Label key. What did you? I'm guessing you didn't find. Yeah, I never found it. Okay. This includes. Does that fix it? No. Key, no, it's boxes, 1, find, try that again. Okay, so did find it. Did I do it backwards? There we go. Okay, okay, okay. Now to do this, that's because the filter doesn't work. It needs to be nope, does not include. There we go. Should it be 4? It should only be 3. PC. The PC didn't work. Okay, I guess going back to this. Oh, is there? Okay. So I do need to do this. The label shouldn't be. Actually, no. That was fine. That was fine. No. That was fine. Because that was CP, right? Or PC, right? Yeah. So I got 3. Oh, it's in 2, isn't it? Yeah, it should be in 3. Yeah. Oh. It should be, yeah, it should be removing all of them. Why is it not removing? So OT5, AB, PC6. Oh wait, OT7 should be. OT. Oh. Oh, I see. The replacement doesn't work. Okay. And it replaces it. Nice. Okay. Okay. That's what's going on here. Right, because it's label. All right. Fine. You're gonna make me have a type for this. Label string. That's how I spell label. Wow. Label string focal. Fine. Make me have one. Okay. So what's gonna happen now? We need to do s dot label. All right, so anything changes here, so we need this. What we need to do is if index is going to be equal to this, find like so. Okay. So there's the label, and then I also need the focal, which is going to be but this. Ooh. This one. That. Okay. So if index equals -1. Do what we were doing, which was this, putting this in. Filter. Actually, there's no filter needed. We just dump it in. And then you can just do label focal. Otherwise, it does have it, so you need to do boxes equals boxes dot map. Actually, that should not be needed because it should have it. Map. Label. L dot label. And then the only thing that changes is focal. Actually, I do need I. Focal is I equals index. Set it to focal, otherwise head to L dot focal. Alrighty. Lens focal. Fingers crossed. Find index 24. Oh, I guess this could be empty. What the heck? $145. Alrighty, there we go. Alright. I get rid of this now. Where is my input now? Alright, that was a little bit more work than it needed to be. I'm wrong again. No, don't tell me I'm wrong. Wait, what? $145. No, wait. I got No, I got the test code for it, but not mine. Uh-oh. That's not good. Because I'm not sure then what I did wrong. Label cannot be in multiple, obviously, because they all have the same thing. So I actually box them. So I'm actually going to remove it. I can just do this. And then I can just do I don't think it's gonna give me a different answer. Oh wait, it did. 262759. Why'd that give me a different answer? Why'd that give me the right answer? Okay, wait. I'm not sure what I did there. Interesting. Okay, well. There we go. Alright. Yeah, 1 second. Alrighty, and there we go. Day 15 is complete. Honestly, this was an easier one to do. I still tripped up on it just because, again, TypeScript, getting used to doing these problems in TypeScript. But overall, no, this problem is not that difficult at all. I also misread the logic for part 2. with getting confused about the whole box is 0-bit. It's because it's just that. But at any rate, yeah, so for doing this one, so the first step is given our input, break it up into individual operations. Part one is simple. We have this hash function. It gives you the formula. It's pretty simple, and again, just a bunch of reduces to sum things up. You just chuck that through the hash, and that's it. Pretty straightforward. Part one, good. Part two, a little bit more difficult, but honestly still not that bad. Each operation either has an equal sign or a dash. If it's an equal sign, you're adding in the label and lens into the box, with the index of the box being the label, key point being the label. The label is just this bit. Be careful when you're reading. Don't do it. But given the label, you just get the hash, which is the box, and then in the box you simply, if the box already has this label, you replace the lens in that box with this. Replace the label's lens focal with the new one that you're putting in there, but you don't change anything about the box. Otherwise, you put the lens at the very end of the lenses in the box. If you get a dash, you get the same thing, calculate the box number for the label, and then due to that box number, you're removing this lens with this label from the box entirely. And then again, go ahead and do some sum logic based upon the math formula they gave you to get your answer for part two, and that's about it. Pretty simple, pretty straightforward. Not too difficult, just gotta read carefully, unlike I did. But at any rate, there we go. Day 15 is complete. Thank you guys for watching. I'll see you guys all tomorrow for day 16. Peace out.